If the future of nuclear power can succeed, then we're going to make a big difference when it comes to climate change. The US government needs a solution for waste disposal. We've been working on this as a country for almost 50 years. We haven't seen a lot of progress because the technological solution that we've chosen, that of a mined repository, is extremely difficult to implement. But that doesn't need to be the case. With boreholes, there is an opportunity to move forward inexpensive, timely, very safe, and it can be implemented modularly. We can really finally address nuclear waste disposal, which will in turn allow us to move forward with the greater use of advanced reactors, SMRs, and a future for nuclear power.
As of right now, there's over 400,000 tons of nuclear waste in the world.
Deep isolation as a business is founded to answer that question, to give a cost-effective, safe, scalable global answer to that question. What are we going to do with the waste?
Technically, it's not a difficult problem to solve. We have the technology to do it. It's a matter of putting the pieces together.
Deep isolation solution is simple and something that can be implemented very quickly. With grant funding from ARPA-E, we are developing a universal canister system for advanced reactor waste streams. We're developing this to be compatible across all of the advanced reactor industry. Once the waste gets loaded and encapsulated into this canister, it never has to be reopened. It is future-proofed.
Deep isolation technology is really kind of combining the oil and gas industry and the nuclear waste and transportation industry.
The Universal Canister System project is really developing two things. One of them is a canister designed to accommodate waste streams coming out of the advanced reactor field.
When we start a borehole, we move a drilling rig on site. They would then start to drill that hole that's very straight and smooth. That allows us to place canisters without getting them stuck. We use tools to move that waste further down the horizontal. We can do that very safely and make sure that's placed very precisely. We continue to take waste at the top, attach that to our emplacement tools, and deliver that to the bottom until we fill up that horizontal section.
This is a technology which gives communities choice in how they dispose of nuclear waste. And because deep boreholes can go much deeper and directional drilling can seek out safe isolated rock formations, it opens up many more communities.
Deep borehole disposal for spent fuel and high-level waste, I think, is really advantageous compared to a traditional mine concept, especially if you're looking at some countries that have maybe a low inventory of fuel. This is a smaller modular system. It's faster, it's going to be cheaper, it's going to be safer.
Deep Isolation have been partnered with a number of well-established companies that really know what they're doing, both in the nuclear industry and in the drilling oil and gas industry.
From the very first meeting that we had with Deep Isolation, it was pretty obvious this was probably the best answer anybody's come up with yet for disposal of nuclear waste.
Deep isolation's technology would be very valuable for Ukraine, precisely because it provides, on one hand, flexibility between putting spent fuel in existing storage systems, and on the other hand, using the deep borehole technology.
We really enjoyed the experience working in deep isolation. Not only do they have experienced nuclear professionals, they bring the right approach of innovation.
We can respond to what we know is the key that will unlock this multi-billion-dollar global market.
It's not overstating it. You can change the future of humanity by pulling this off.
I believe that the nuclear waste disposal issue is solvable. We can do this. There is no significant barrier to keeping Deep Isolation from successfully disposing of nuclear waste, and that would unlock a brighter future for the nuclear industry and for the world.